This next unit, we are doing more confidence intervals and hypothesis tests. So this unit, we are doing 3 more confidence intervals and 3 more hypothesis tests. But they're very closely related to what we've already done. You're still going to do the 4 C's. You're still going to choose a procedure. You're going to check pretty much the same assumptions. You're going to use very similar formulas. So, going to be a very similar idea. The big difference is we are looking at 2 groups now. So you know how when we've done the choose part, I've been picky about you saying it's 1 sample hypothesis test for mean? Here's why, because now we're going to be looking at 2 samples instead. What we are going to start with, though, is what we call paired data, which really we've already done. It just looks a little bit different. So there's some things that you're going to need to know how to do on the calculator that we'll talk about. There, of course, is your formula sheet. So some of this we've seen before, like for proportion, we've seen this first line where there's 1 proportion. We're now going to be looking at this next line where there are 2 of them. For mean, same idea. We're going to be looking now at the case where there are 2 sample means. What I need you to do is find this section 10.3. So like I said, all the way at the back. We're just going to start with an example of designing a study, and then we'll actually do the procedures when I see you next class. A pharmaceutical company has developed a new drug to lower cholesterol and wants to compare it to the drug that is currently being recommended by most doctors. To do this, the company recruits 20 male volunteers, all similar in age. Half the subjects will be assigned to the new drug, and the other half will be assigned to the current drug. There are 2 different ways that we could do that. The first one is a completely randomized design. What that means is you take those 20 volunteers and you somehow split them into 10 and 10. How do we normally do that? Hat method. That's pretty much the best way. So that would be something like write all their names on pieces of paper, put them in a hat. What do you absolutely have to say? You're definitely mixing that hat, and you'll choose 10 without replacement, blah, blah, blah. That kind of thing. So then 10 will get the new drug, and the other 10 will get the, is it current? Is that what it says? Current. So that we've seen before. So at the end, what we would do is when we would compare, we would have to compare the new group to the current group. So we have 2 different groups that we're comparing. The group that took the new drug and the group that took the current drug. The other thing that we've talked about is a matched pairs design. So a lot of times when we were designing experiments before, we used matched pairs designs. We didn't necessarily use that term, but really that's just a block of size 2. And if you remember, oftentimes what we did is we would take those 20 volunteers scratch that, sorry. When we talk about a matched pairs design, we need blocks of size 2. The people in those blocks need to be as similar as possible. And we need to match them up on something that is not cholesterol. So what do you think could be related to cholesterol besides the drug that someone's taking? Gender. They're all male of the same age, though. Diet. What? Blood pressure, maybe? That's a good one. I like blood pressure. So what we would do is we would block on blood pressure. So what that would involve doing is we would measure the blood pressure of all the subjects. Then we would pair up the 2 highest, the next 2, etc., all the way to the lowest 2. So what I mean is the 2 people who have the highest blood pressure are 1 block. Then the next 2 are a block. And then the next 2 are a block. Within each block then, 1 person gets the new treatment, 1 person gets the current treatment. How do you decide, though, which one gets which? Because we have to randomize, remember. And our randomization here was the hat. How do I decide if I have two people, which one gets which treatment? Okay, flip a coin. Sure. And then we flip a coin. I'm going to say heads is the higher BP gets the new, tails, so on and so forth. All of this should be reviewed. We've already talked about that. That just comes from before. So I'm not super concerned about that. What I'm concerned about is how would we analyze this data? We would not analyze it the same way as we did up here. We wouldn't look at the new compared to the current, because then that completely ignores the purpose of having a block. So in a case like this, where you have what is called matched pairs, or you have blocking, so matched pairs or blocking, what you do is you look at the data of the differences. What I mean by that is I don't care about man 1 and man 2 in the block. I don't care what their cholesterols are. Instead, I'm going to subtract the two and get a difference for every block. So then all you would do is you would analyze the differences. We're going to write down one more thing and then we'll be done. So how do we do inference? When it says inference, that just means a confidence interval or a hypothesis test. So how do we do an inference? How do we do a confidence interval or a hypothesis test for paired data? Like in this case where we're pairing the men together. We start by calculating the differences. Then, after we have the differences, we do a one sample T procedure for those differences. This second line, this is what we've already done. This is what you did on the test. You did a one sample hypothesis test for mean. The only difference now is you have to find the differences first. And then you're doing the exact same formula, checking the exact same conditions.